All right, this is the solution video for section 5.1, problem number 3. All right, so we got it set up. We have the area of the printed region is x minus 2 times y minus 3 halves. All right, and so what I need to do is I now need to solve this area of the total equation for one of the variables. All right, so let's say I'm going to solve for x. So x is going to equal 90 divided by y. All right, and so that means I'm going to take x out and put 90 divided by y in. Now, you could also solve for y and get 90 divided by x and then sub it in there. So the area of the printed matter is going to be 90 over y minus 2 times y minus 3 halves. So now I have an equation in one variable, and so now I can go ahead and find the derivative and set it equal to 0 and solve. All right, and so first thing I want to remember is this 90 divided by y is just 90y to the negative first, right? So then when I'm gonna, take the derivative, I have it a little bit easier. All right, so you can start off by using the product rule if you want. So a prime is going to be 90 y to the negative first minus 2 times the derivative of y minus 3 halves, which is just 1. All right, and then plus y minus 3 halves times the derivative of 90y to the negative first. So that would be negative 90y to the negative second. And then minus 0, obviously. All right, so now here is a prime. Now we're going to set this equal to 0 and solve. But first of all, I'm going to take and simplify this. So 90y to the negative first minus 2 times 1, obviously, and then plus. Now I'm going to distribute that. So I get minus 90. And then this is what? Y to the first times y to the negative second. So add the powers together. So I just get y to the negative first. All right. And then plus 3 halves times 90. So the 2 and the 90 reduce. So that would be 45. All right, so 45 times 3 is 135, so 135 y to the negative second. All right, and so now I've got 90 y to the negative first minus 90 y to the negative first, so those obviously just subtract out. And so I am left with negative 2 plus 135 y to the negative second. All right, so now I want to solve. All right, so I'm going to add 2, and so I get 135 over y squared. All right, so I'm going to multiply by y squared, so 2y squared equals 135. So divide by 2, y squared equals 135 divided by 2, right? So 135 divided by 2, I'm just going to write it here. All right, and then I'm going to square root. So y equals obviously plus or minus, but the minus is really never going to make sense in this setting. So the square root of 135 divided by 2. All right, and so now we get our value here. All right. All right, and we want to make sure that we realize, obviously, that the positive is not going to be a value. All right, and so now we want to do a sign analysis to determine or to verify that we do, in fact, have a maximum occurring there, right? All right, so let's go ahead and set up our sign analysis. So the square root of 135 over 2. All right, and so our derivative really boiled down to just that negative 2 plus 135 y to the negative second, right? And so now we get a 0 here, all right? And so now we want to evaluate something on the right and the left. All right, so what if I plug in something to the left like 0? Well, 0 doesn't work, right? Because you have 135 times y to the negative second, right? So that would be undefined. But what about 1? Okay, is it clear that a square root of 135 seconds is larger than 1? Okay, so I'm going to plug 1 in, right? So negative 2 plus 135 times 1 to the negative second. So that would just be negative 2 plus 135, which is positive. All right, and then a number to the right of this. How about like, I don't know, something like 10, right? Just because uh, so 135 times 10 to the negative second, that would be 135 over 10 squared, right? Which is 135 over 100. And so negative 2 plus that is, of course, going to be a negative number. And so positive to negative, remember, indicates that there is indeed a maximum there, right? And so then we need to think about, okay, well, then what would the dimensions be, right? So if this is y, right, then we need to find x, right? So x is just 90 divided by y, right? So x would be 90 divided by the square root of 135 seconds, right? And so that would be our x value. That would be our y value. Obviously, then we would want to do a calculation on these values to make sure that we have the correct values. All right, and so um, we're going to do that calculation quickly. All right, and so the square root of 135 over 2 gives me that y is approximately 8.216, and this would be inches. All right, and so then I'm going to take 90 divided by that value to get the x, which is approximately 10.954 inches. So remember, we have to answer the question, find the dimensions of the page, right? And so the dimensions of the page would be 10.954 by 8.216 inches, right? So remember, 10.594 is the width and 8.216 is the height.